Hi, my name is Kimberly Harris, and I'm going to be going over section 2.3, parallel lines. A parallel line is defined as any set of lines with the same slopes but different y-intercepts. And this is on page 175. Okay, so this is example 10, and it's on page 175. This is showing that two lines are parallel. And what I've done, this is line 1 and line 2, these were given. And the first thing I'm going to do is go ahead and put this into slope-intercept form. And that's just here, it's y equals mx plus b. Alright, so all I've done over here is just rearrange the problem, y equals mx plus b, y equals mx plus b. That's all I've done. Alright, and then I just simplified. Over here we had to divide by 3 to get rid of this 3. Okay, and that gave us our slope and our y-intercept. In line 2 we did the exact same thing. Over here it was a 6 though, so we did divided by 6, and that gave us our slope and our y-intercept. You'll see here that line 1, the slope was negative 2, 3x, and line 2 was negative 2, 3x, so they do have the same slope. Our y-intercept for line 1 was 2, and our y-intercept for line 2 was 0, so they do have different y-intercepts. So that meets the criteria for parallel lines, so you would write L1, or line 1, is parallel to line 2, and that's how you would write that right here. Okay. So moving on to example 11. Ooh, the light's a little weird, I'm sorry about that. Let's see. So all I've done here, this is just how to find a line that's parallel to a given line. And our example that was given to us is find an equation for the line containing points 2, negative 3, and is parallel to the line 2x plus y equals 6. Okay, so the first thing that I'm going to do is go ahead and put the given line into slope-intercept form, which is just like what we just did. We're just going to rearrange the problem so that it's y equals mx plus b. Okay, and we're just going to call that line 1 and put it to the side. Now this is the point slope form, and we're going to use this, we're going to plug in the information that we already have to create a new line that's going to be parallel to our first one. Okay, so point slope form is y minus y1 equals mx minus x1. Alright. And the way that we do this is we're just going to plug in the point that we have and the slope that was given to us. So we'll look at that. 2 is our x, negative 3 is our y, and our slope is negative 2, and you can get that from up here. That's what was given to us. Okay? So we're just going to plug that in. So we're going to have y minus, then negative 3. Okay, that's y. Then m is our slope. We got that here. Okay, and then x minus x1, which is 2. Okay, so it's going to look like this. And we're just going to simplify this, and we're going to get y plus 3, watch your signs there, equals negative 2x, and we're using the distributive property to get plus 4. Alright, we're going to simplify that just a little bit further and move our 3 over. That's going to give us y equals negative 2x plus 1, and that's going to be line 2. Alright, so we're looking at line 1. Let's look at our slopes, negative 2x, okay. Our slope for line 2 is negative 2x, so our slopes are the same. Then our y-intercepts for line 1 is 6. Y-intercept for line 2 is 1. So they do have different intercepts. Okay, so that means that line 1 is parallel to line 2, and that's just a way that you can kind of check your work to make sure that, you know, they are parallel. Okay, so that's pretty much it for parallel lines in section 2.3. Have a great day.